All right. So today we're talking about applications of arithmetic and geometric patterns. You guys are going to be able to apply these things to the real world. Isn't that right, Zach? Mm-hmm. Okay. So we're going to explore two possible applications with arithmetic and geometric sequences and series. Those are going to be dealing with interest and population growth. Okay. At least those are going to be like the two that we're focused on today in class. Okay. And I do realize that arithmetic and geometric sequences and series go way beyond interest in population growth. Okay. For example, you work at Publix and you're in charge of creating the beautiful triangular display for the Super Bowl. Okay, with the different boxes of Coke cans that they like to have in Publix, right? And you have to figure out, okay, I want to create this little pyramid with all the boxes. How many, what is the largest number I can put on the bottom to create a pyramid? That's an example of like an arithmetic sequence. Okay, it doesn't deal with interest in population growth, but it's still an arithmetic sequence. Or better yet, you are an orchestra director and you are in this amphitheater and you're trying to tell the people in the front, like, hey, I want to make sure that I sell out this many seats. That's another example of an arithmetic sequence dealing with the number of seats that are inside of that amphitheater. So, but talking about these two possible applications, interest, okay, is the charge for borrowing money. If you go to school and you do not get a full ride scholarship, you probably are going to have to take out a loan. Try not to do that. Try to get as many scholarships as possible. But if you do take out a loan, or even if you get a credit card, okay, that company that you borrow money from is going to charge you interest, okay? It can also be described as money earned on an investment account. So, you get a credit card that has a $500 limit. Anytime you use that credit card, you're borrowing money from that company, which means that when you pay it back, if you don't pay it back within a certain window, they're going to charge you a certain amount of interest for borrowing that much money. Okay? And they usually tell you how much they're going to charge. Your normal flat rate is anywhere between 24% and 29%, which is a lot. Okay? So if you borrow $100 from them and you don't pay it back within like a very short window that they give you, then you'll have to pay back $124 or, you know, $129. Okay. There's two types of interest though, simple and compound interest. Okay. A lot of times companies, loan companies, Department of Education, all those, they use compound interest. Okay. And compound interest basically means they're charging you interest a certain period of time in within 1 year. Okay. So let's explore these two. You guys are going to do a little activity, a little investigation. So simple interest is interest paid on the initial amount borrowed, saved, or invested only and not on past interest. So that basically means whatever you originally invested, that's how, and you figure out what is the amount of interest based off of the percentage, that's how much you're adding every month or every year or every whatever. So compound interest is interest paid on top of interest. That's what many loan companies do. All the credit card companies do that. Anybody else who you borrow money from. Okay? So again, if you can avoid student loans, please do. Apply to those scholarships, okay? Please, y'all. I wish we had when I was in school someone who was strictly for scholarships, okay? Trust and believe. My parents would have been paying out of pocket for me to go to undergrad. Simple interest can be modeled by an arithmetic series. This is your formula here. A equals P times 1 plus NR, where A represents the accumulated amount. So basically how much you've gotten after a certain period of time. P is your principal, how much you start with. R is your annual rate. And N is your time in years. Yes, question. Yes. So N is the time in years. So if it's 6 months, then yes, you would plug in 1/2 for your N. Okay? 9 months would be what? 3/4. Okay? If you're ever confused, just do 9 divided by 12 and boom, you're there. Okay? Compound interest can be modeled by a geometric series. Okay? A equals P times 1 plus R, that quantity to the nth power. A, P, R, and N are the exact same A, P, R, and N from before. Okay? Now, the only thing about compound interest, though, is that it can be given in many different ways. Annually, or you'll see something that will say per annum. That means annually, basically. Okay. This will be where you just get it one time a year. One time. It's the only time you're getting your interest. But a lot of other times it will be quarterly or monthly, like in your investigation, or weekly. So in those cases, you're not going to be able to use this general formula because this only applies if it only hits one time a year. So if you be paid over any time period, like I said, yearly, monthly, quarterly, then you want to use that formula that you see there. Okay? And this is the formula that's in your reference booklet. None of the other ones are in your reference booklet. Okay? In this case, N is not the number of years. That's what T stands for. N represents the number of compounding periods per year. Number of compounding periods. And again, T represents the total number of years, so time, if anything. So if it's quarterly, you gotta think, how many times a year is that? It's 4. There's 4 quarters in a year. Okay? And there's 4 seasons in a year. Monthly, how many periods is that? How many compounding periods is that? 12. How many weeks are in a year? So weekly would be 52. And then you have daily, which would be 365. We do not consider leap years. Okay? We do not consider leap years. So anytime it says anything of that nature, you have to plug in one of those numbers for your value of N. And in this case, and in this formula, N represents the number of compounding periods per year. Get down what's important. Get down what's important. Sebastian took out a loan for a new car that cost $35,000. The bank offered him 2.5% per annum simple interest for 5 years. Calculate the total value Sebastian has to repay the bank. If you thought your parents just walked into a car dealership and paid $24,000 cash on a car, you'd be mistaken. Okay? A lot of times, normal people can't afford just to walk into a car dealership and buy a car flat out, unless they're a drug dealer. Okay? So they usually go in, they put a certain amount down on the car, and then from there, the finance company figures out based off of their credit, based off their past payment history of cars, like when they've had other cars before, and then they basically get the interest rate and then basically set up a repayment plan that calculates in the interest. Okay? And that's how buying a car works. All right? Now those buy here, pay here type places, those do things a little different, but I'm talking about like straight from the dealership. Okay? So, simple interest. Those are key words right there, because then you'll know what formula you need to use. So since it's simple interest, that's A equals P1 plus NR, and in this case, N represents what? Time in years. Okay? How many years are we dealing with here? 5 years. What's my rate? 2.5%. when you're dealing with it in these formulas, rate is always as a decimal. This is a percentage. So what is it as a decimal? 0.025. Then I have my 1. What's my P? What's my principal? And what does A represent? The total value. So go ahead and figure that out. How much is Sebastian having to repay? 75. And it stops right there. Okay. Real world. What do you notice? He has to pay more than what the car was originally worth. Yes, that is the truth of the matter. Unless you're walking in and paying $24,000 for the sticker on the car, cash money, you're going to be end up paying more than what the car is actually worth. Okay. Has anybody ever heard of oh my God, what's the term? Refinancing their car? Okay, people think refinancing is a good thing. To be honest, is really, in my opinion, it's a trick. Because basically what it does is it takes however much you owe on the car, and they basically set up a whole new payment plan, which yes, it does lower your monthly payment, but again, you end up paying even more than what you would have originally paid on the car if you just kept it the same amount. Because they lengthen your loan, or let's say you got a loan for 5 years. You pay for it for 2 years and decide to refinance the rest. Well, now you've gone from only having to pay for 3 more years to now paying for 4 more years, and you've increased your amount because you increased your time. Does that make sense? So, soon to be car drivers, some of y'all probably already drive, hopefully legally. This is the world you're getting into. Called adulting. 50-50, it sucks. Okay? 50% of the time it sucks, 50% of the time it's great. A B puts 5,000 into a savings account that pays 4% interest per annum compounded monthly. That's a really good thing. How much will be in the account after 4 years if a B does not deposit or withdraw any money? Is it simple interest or compound interest? It's compound, and more specifically, it's being compounded monthly, not annually. So we need to use the formula where N this time does not represent years, it represents what? The number of compounding periods. So, what's the number? 12. So that goes in 2 different places. What's my rate? 0.04 because it needs to be as a decimal. And what's my time? 4 years. How much does he initially invest? 5,000. Raise your hand if you have a savings account. Good. Save it. Don't touch it. Okay? I doubt you're looking at 4%. You're probably looking at like 0.1%. Maybe 1. You're lucky. Let me know what bank that is so I can get my savings account in. Okay? Banks usually don't offer that much for savings accounts anymore. Okay? But how much would he have after 4 years? $58.65. Okay. Give me 2 decimal places. We are talking about money here. So then it is not too bad, not the best. There's more money than what he started with, and it's in the savings account. Easy stuff, right? That's him. The other one, because what the other geometric formula, the one that's just for compound interest, doesn't take into the fact that basically when it's being compounded compounded monthly, that means you're getting a portion of that rate every certain number of months in the year. So in this case, you're only getting a fraction of that 4% interest divided out over 12 years. So it's not like you're getting 4% first month, 4% second month. No, you're getting 4% in total. It's just split up over 12 split up over the year. 12 months. And I don't know a bank that does that either. It's usually, actually no, my bank account doesn't do that. Doesn't they hit me with like a dollar fee? So the more money you invest, the more that you will have. Hold on, wait, don't write this one down. I'm looking at like the problems we have left. Okay. Yeah, we can do both. Leslie, you got a student loan of 12,090 CAD, stands for Canadian dollars, to pay her tuition at the University of Toronto this year. Leslie has to repay 16,000 Canadian dollars in 2 years with the annual interest rate if the interest of the loan is compounded monthly. Okay? Simple or compound? Compound. And I'm telling you, you always know because it will say it. Compounded monthly, simple interest. A lot of times it will be bolded in the IB question, so you'll know which one you're working with. Which variable am I solving for? Say again. R. If I'm solving for R, what's A? 16,000. You sure? What's A stand for? The final amount? Okay. P? What's P? So I'm solving for R. What's N? 12. And what's T? Okay. This time I'm solving for R. It's inside of parentheses. It's being raised to an exponent and being multiplied by a number in front. So algebraically, how do I solve this? Now, whatever you do, because I'm almost certain that this is not a nice fraction, don't round this. Don't round that fraction. Okay? So whatever 16,000 divided by 12,090 is, I now have 1 plus R over 12 to the 24th power. What do I need to do here? What is it? I need a 24th root this whole thing. If it was a 2 up there, I could just take the square root and be done. But now I'm taking the 24th root because it's a 24 in the exponent. How do you do that? I showed you guys. Who remembers? I got to go to math. So I go to math. Ooh, let me get out of this. Second quit. I go to math. Option 5. Remember, 5 gives me the little x. What am I going to put there? 24. And now I'm going to put that giant fraction, but it's really and truly just a division problem. And all of it's still underneath the root. Are we okay? So now I have this. But I'm not done. What do I need to do from here? I need a minus 1 from both sides. And then multiply it all by 12. So my R is what I get when I take this number, subtract 1, and times 12. Bless you. Now that decimal, rounded to 3 significant figures, would be what? 0.141. Is that my percentage rate? How do I get to a percentage? So my interest rate is 14.1%. Questions? Sure can. And while I'm helping Austin, can you guys work on this one? So Oliver's savings account now has a balance of $900. If the interest rate of 1.5% per annum compounded quarterly, how much did Oliver originally deposited 6 years ago? He has not withdrawn deposited any money since. So $900 was in the savings account now. We're trying to figure out how much he initially invested, and it went at a rate of 1.5% quarterly for 6 years ago. What goes in my numerator of this fraction? 0.015, because it was 1.5%. What's in 4? So pretty much all you were doing to find P was dividing 900 by whatever this number was, correct? And the 2 decimal places, we are talking about money. What do you get? Just read the number straight. 822? 68? Did I hear that right? That's how you deal with interest. Compound. Simple. Interest. Simple concept. Okay? All right. We're getting a new sheet of paper? We must be getting a new sheet of paper. Okay? We still got to talk about population growth. Remember, 2 concepts, 2 main applications, interest and population growth. Okay? The world we live in. This world cannot contain all of us at this point in time. Okay? It really can't. I have my conspiracy theories, but I won't share those with you all. Okay? The population growth is defined as the increase of the number of individuals in a population over time. Okay? We are using up our natural resources. The chicken and beef that we're eating at these fast food places is not chicken and beef anymore. Okay? It's the truth. You cannot tell me that there are that many chickens, that all the McDonald's, all the Chick-fil-A, all the Popeyes can produce all of them sandwiches. No way. I know the truth. And it is based on, population growth is based on the number of births and deaths over a certain time period, certain amount of time for a given population. Okay? So, population growth. We'll talk about it a little bit more deeply because for your homework, you guys have another investigation. Okay? And we're going to take a look at that. Or you guys are going to take a look at that, and then we'll finish this up on Wednesday. Okay? But have you learned something today? Okay? If anything, you at least know how the real world works. Okay? And that if you're not smart with your money choices and your money decisions, you can end up in some major debt. Okay? You can hit your credit.